Good morning. Today we are going to discuss clock latch or flip-flops. In the previous class, we discussed what is a latch and we discussed two latches, NAND latch, NAND SAR latch and NOR SAR latch. And in our in all these flip-flops and all, we are using NAND latches. And what's a clocked latch? Data stored in latches should be retained. That means, uh, in the previous class, we discussed how data can be retained in an SR latch. For example, suppose your input is say 1 1 to an AND latch. That means S and R are 1. Then that is retained. The previous value of Q and the previous output value is retained. And if it is 0 1, 0 1 means the Q input is set, and if it is 1 0, if S and R are 1 and 0, then that will be reset. Okay, now data stored in latches should be retained. So a control on the data is needed, and the control input or enable input or gating input is known as clock. That means there should be some mechanism to retain that information. That means there should be some control. That means in that latch you have two inputs and two outputs. Inputs are S and R and outputs are Q and Q bar. And when these data has to be updated, or for how much time that is to be retained, for all these things there should be some control input. There should be a control input, and that is provided by the gate. That means here you have a clock signal. A clock is a square wave. That means it is going from low to high to low. That means this low signal, low is called 0, and this upper high is known as 1. High is 1 and low is 0. And these are voltages, and this is voltage 0, this is plus 5 or plus 12 or something like that. And this is a periodic wave, and the period of this is t. And as it is a square wave, it is going from low to high, and from high to low, from low to high, and from high to low. This is level. That means from this point to this point, this is retaining some voltage, and after that it is from high to low, and this is level trigger level. And from level 0 to level 1, it's again moving. That means it's a positive edge. This is called positive edge. In positive edge, we are going from low to high, and this is the trailing edge, or this is the negative edge. That means it is going from high to low. This is from low to high, it is positive edge, and this is negative edge, and this is level. This is level. That is regarding the clock. And when the clock is high, latch is triggered, and usually level triggering is applied. That means when this clock is in a certain level, that means when this clock is at this level, that means at this much time, that clock will be high, and the latch is triggered. That means here, see, I'll show you that how that is working. And the flip-flop is like this. It's a combination circuit having an input and an output. It's just like a sequential circuit, and the memory, this is the sequential circuit. That means combination circuit plus memory is called a sequential circuit, and that memory is triggered by this clock pulse. Whenever this clock is 1, the memory is triggered, otherwise this circuit is not enabled. That means actually this is an enable input. And triggering methods, there are 3 different triggering methods. That means this is enabled when this clock is at level. That means, as I told you, this is from this point to this point, it is at a particular high level, and at this point in time this memory is activated. If it is positive edge trigger, that means the positive edge of the clock. That means here this is positive edge of the clock, this is another positive edge, this is another positive edge, this is another positive edge, and in this positive edge of this clock that will be triggered, or when this positive edge is there, then this memory is activated. If negative edge triggering is there, then for this trailing edges, that means from high to low, if there is, and at this point this memory is activated, that is negative edge triggering. So positive edge triggering is there, negative edge triggering is there, and level triggering is also there, and that is regarding clock. And now we are going to discuss how an SR flip-flop is working. As I told you, this is an SR latch. This is SR latch, and we are attaching one more circuit here. This is S and R, and this is the clock pulse. This is the clock pulse. And when this clock is 0, suppose that the clock is 0, see, when this clock is 0, what will happen? These are two NAND gates. These are two NAND gates, and this NAND gate and this NAND gate, the output will be 1. See, as this is 0, and this, when 0 is ANDed with whatever be the value of S and R, when this clock is 0, what will happen? When this clock is 0, what will happen? That S and R, that it means irrespective of what the value this S and R have, this clock, as the clock input is 0, these two S star and R star will be 1. That means if this clock is 0, whatever will be the value of S and R, S star and R star, these two values will be 1 and 1. As you know, in your NAND SR latch, as you know, we have studied that in your NAND SR latch, if S star and R star are 1 and 1, it is retaining the previous information. Retaining the previous information. So, when this clock is 1, that means when clock is 0, whatever be the value of S and R, we have, there is no need to there is no need to watch the value of S and R, because as clock is 0, these AND gates, retain, the output of these AND gates will be 0, and when that is negated, the both of this S star and R star will be 1. If clock is 0, S star and R star is 1 and 1, and if S star and R star, S and R are 1 and 1 in NAND latch, NAND SR latch, it is retaining the information. That is why whatever be the value of Q in the previous case, that will be retained. That is why I put here memory. Then if clock is 1, that means here suppose that our clock is 1. Clock is 1, that means level triggering. And suppose the value of S and R are 0 and 0. Suppose that this is 0 and this is 0. When these two are ANDed, 0 and 1 are ANDed, it is 0. Here 1 and 0 ANDed, it is again 0, and when it is negated, here it is 1 and 1. Again that is treated as, that means S star and R star are 1 and 1, so it is retaining the previous information. In that case also, it is behaving like memory. It's behaving like memory. If clock is 1, S and R are zeros, it is behaving like memory. Now we are going for clock is equal to 1, and S equal to 0 and R is equal to 1. S equal to 0 and R is equal to 1. What will happen? This is 1 into 0, 0, and when it is negated, this will be 1. And this is 1 into 1, 1, and that is negated, this will be 0. And S star is 1 and R star is 0. S is 0, S star is 1 and R star is 0. As you know, in SR latch, when S equal to 1 and R is equal to 0, that will be reset. That means this is S bar and R bar you have to take. In that case, this is S star is equal to 1 and R star is equal to 0. What will happen? The value Q is reset. That is, here it is 0 and here it is 1. Okay. Now, see, if the clock is 1, here it is 1 and here it is 0. Here it is 1, here it is 1 and here it is 0. S is equal to 1 and R is equal to 0. What will happen? 1 into 1 is 1, negation, here it is 0. 1 into 0, here there will be 1. And when S star is equal to 0 and R star is equal to 1, what will happen? This Q is set. This Q is set, that is why here Q is set. And Q bar is this one. And when clock is equal to 1, R is equal to 1 and 1. This case, here 1 into 1 is 1 into 1 is, here it is 0 and here also it is 0 and 0, and this case is not used. This is not used in SR flip-flop. So this is the truth table for that, and simply speaking we have, this is a sequential circuit and you have S and R as the inputs, and if you are providing clock signal here, this is the SR flip-flop, and depending on the current value, this is the depending on the current input and the current value of S and R, we can activate or we can have an enable switch. This is clock signal is otherwise called enable switch, and when enable is activated, the depending on the value of S and R, that Q and QR will be set, reset, or it will retain the information. Okay, that's all about SR flip-flop. We are going to discuss JK flip-flop. In SR flip-flop, we have now we are going to discuss JK flip-flop. In SR flip-flop, there is a not used condition. That means in that SR flip-flop, if S and R are 0 and 0, the memory value or previous value of Q is retained. Then if it is 1 0, it is set, and if it is 0 1, that will be reset. The value will be reset, and 1 1, that is a condition which is not used there. Now we are going to make use of that 1 1 when S and R are 1 and 1. To make use of this particular state, here this is an SR flip-flop, and here in this SR flip-flop I am going to make a small change. That means here I am going to feed this value to S, and Q bar is given as input to the first NAND gate, and this Q is given to this NAND gate. Okay. Now I am going to rename this S and R as J and K. This is JK flip-flop. This is called JK flip-flop. That means, what is the difference between SR and JK flip-flop? I have renamed this S and R as J and K, and only difference is here you have taken this Q output to as the input to this NAND gate, and Q bar is taken and that is what as input to the first NAND gate. Okay. Now suppose that the clock is 0, then what? Now I am going to rename this as J and K. Whatever be the value of J and K, if the clock input is 0, this is 0 and this is 0, then this here it is 1, here it is 1. Here if this clock is 0, this is 1 and this is 1. When this is 1 and this is 1, the value will be retained. Okay. Then regardless of what the value of J and K, this is memory. This is memory. What will be the value of X and X? Regardless of what the value of J and K, if the clock is 0, this is acting as the memory. That means the previous value is the next value. Un is 2n plus 1. Now, if the value is 1, what will happen? If the value is 1 and if j and k are, suppose that it is 0 and 0, what will happen? If it is 0 and 0, if j and k are 0 and 0, then definitely this will be 0 and 0. Again, that is acting as memory. That means previous value for qn plus 1 is equal to qn. Qn plus 1 is equal to qn. And now, suppose that the clock is 1 and suppose that this is 0 or 1, okay, 0, 1. And the value of j is 0 and the value of k is 1. When j is 0 and k is 1, and suppose that the clock input is also 1, what will happen? This is, as this is 0, this will be 1. That means NAND gate is producing an output of 1 if either of the input is 0. Here, see, I can have a conclusion about what the value of this. Here it is 1, we know that, and see, here it is like this, and suppose that the previous value of this is 0 and this is 1, then what will happen? The input is 1 and here also it is 1, and 1 into 1 is 0, and 1 into 1 is 1, and when it is negated this is 0. That's okay. And 0 is fed to this input, 0 is fed to this input, and 0 into 0 is, and the output will be 1, and that is stabilized. That means this is 0. That means this value, that means if it is 1 0, what will happen? And see, here one more change is there. This 1 is fed here, and that makes that doesn't make any change, because of this the value of this is 0 regardless of what the value of this is, this and this, the output will be 1. And what about 0 is fed here? 0, and 0 into 1 into 1 it is 0, and here the output will be 1. Here this is, as this is, see, as this is 0, 0 into 1 into 1 is 0 and the negation is 1. Then that 1 is given here. You know that this is 0 and this is 1. 1 into 0 is 0 and that is 1. Now it is stabilized. That means as this is 1 and 1, and here this is reset. That means when it is 0 1, this will be reset. That means qn plus 1 is equal to 0, whatever be the value of qn. Whatever be the value of qn, qn plus 1 will be 0. When j equal to 0 and k is equal to 1, suppose that here the previous value of this q is 1 and this is 0, what will happen? This 1 will come here. We don't know what is the value of all this, and suppose that we know that j is equal to 0, k is equal to 1, and the previous value of q is 1 and q bar is 0. Okay, here in this case, as this j equal to 0, definitely this will be 1, because 0 into whatever this 0, and when you take the negation, this will be 1, and this 1 is coming here, this 0 will come here. Okay, then 1 into 0 and 0, and when taking the negation, that is 1. So okay, and now this 1 is put here, and clock is 1 into 1 into 1, which is 1, and taking the negation, this will be 0, and 1 into 0 0, and this will become 1, and this 1 will come here. 1 into 1 is 1, taking the negation, this will be 0, and when this is 0, this is 0, and this also becomes 0. Okay, then what will happen? As this is 0, this will be 1, and 1 into 0 0, 1, it's okay, 1, it's okay, 0. Now it's okay. Now it's done. Now 1, okay. That means whatever be the value of uh, whatever be the previous value, when it is 0, 1, qn plus 1 will be 0. Qn plus 1 will be 0. Now if j is equal to 1 and k is equal to 0, and suppose that these values are not available, see, all these values are not available. Now see, suppose that this is 0, this is 0 and this is 1, what will happen? Now this value also, this value I know which is 0, and see, as k is equal to 0, definitely this will be 1, and here this output is here 1 into 0, 0, and this will be 1, and as this is 1, here it will be 1, and here also it will be 1, and if these three are 1s, this will be 0, then 1 into 0, 0, here this will be 1, and now this becomes 1, and when these two are 1s, what will happen? This will become 0, and this is 0, and now this is 1, this is 0, and now it is stabilized. That means if the clock input is 1, if j is equal to 1 and k is equal to 0, whatever be the value of x, this qn plus 1 will be 1. Flip-flop, if the value of j and k are 1 on 1, 1, 1, if the clock is 1, what will happen? The output qn keeps on changing. That means it is changing from 1 to 0 to 1 to 0 to etc. That is in a predictable manner, but it keeps on changing all the time. All the time it keeps on changing, and that is uncontrollably changing. That means in a single clock signal, for a single clock signal itself, it is changing a number of times. That is called this is called toggling. That means changing from 0 to 1, 1 to 0, 0 to 1, 1 to 0, etc., etc. And this frequent toggling is called racing. That is the race condition. They may ask you to explain what is the race condition, what is racing in JK flip-flop, and to overcome this racing, we are going for another flip-flop which is called master slave JK, and that I will discuss in the next class. Anyway, the difference between SR flip-flop and JK flip-flop is, here S and R are replaced by J and K, and there is a feedback from Q bar to the first AND gate and Q to the second AND gate, and here in this case, if J and K are, whatever be the value of J and K, that will be retained if clock is 0, and if clock is 1, 0, 0, the memory value is retained. If Qn is A, then Qn plus 1 also should be A, and if it is 0, 1, if j and k are 0 and 1, whatever the value of qn, that will be reset. Qn is reset. The output will be reset. And if it is 1, 0, if j and k are 1, 0, then the output will be set. And if it is 1, 1, it is toggling. That means it is complemented. But in j and k flip-flop, one of the most difficult situation is toggling. That means it is changing, but we cannot control that. It's uncontrollably changing from 0 to 1 to 0 to 1 to etc., etc. So that's called racing. To overcome this, we are going for master slave JK. Okay, thank you.